we've got the name input showing properly, but I think we should maybe add the score. Oh, it shows high score with the score up there. So I think in general we can make this look nicer. Maybe also, can you tell which one is the one that I'm editing at the moment? No, you can't. It's that one. So maybe make the one that we're busy editing blink. Maybe have a little up arrow and down arrow to show how you're going to change it. I'm still considering whether we should add keyboard support, because that is a complicated thing to add just so that it works. And Snake usually only uses the D-pad, so controller support's probably fine. And then we'll probably want some kind of text that indicates that when we press our A button that it commits the name. Although maybe the first one should move it to like the save button, and then the next time you press it, it should save. Cosmetics, we'll do that in the next one. Most importantly is we needed to save this to persistent memory, because if I now, even if I commit this, there it says A, B, C, D, E, H, I skipped G, and 6. If I now reset, it's gone. So we need to get it to save. How we do that? Firstly, TIC-80 has a thing where each cartridge has a certain amount of persistent memory. Let's just call this Classic Snake. Oh, I haven't updated my version number in a while. What is this now? 13? It's called Classic Snake. So you know how the old save cartridges worked, like on PS2, where you had a single cartridge that had a bunch of save games in them, and each of them had like a slot that they occupied? Now, TIC-80 kind of works like that. So you give your game a save ID with a particular name, and that's where it will save the persistent memory for this game on this machine. It's unique to this machine. There's no cloud saves or anything fancy like that, and more than one game that has the same save ID will influence each other's data, so this does need to be somewhat unique. But this allows us to save a certain amount of information, not a lot, but a certain amount of information to the PC or to the device to be loaded again next time we play. So we're calling that, if you don't put in a save ID, it'll do a hash check on the entire file and use that to uniquely identify it. The problem is if you even like add a space somewhere, the hash changes and your save data will go missing, not go missing, be saved in a file that your game no longer expects. Then we need two functions. We need a save and we need a load. So right at the, okay, this is add new scores. Let's put it below. To be honest, it really doesn't matter in what order our functions are inside this file, because we can just, search for them over here. Function save scores end, and then we're also going to need a function to load scores when the game starts up. Save scores. Okay. How the persistent memory works, and let's do it this way. Here's one I prepared earlier. This is nothing fancy, but you give it a save ID of, I don't know, ABC, and then run it, and it prints out the 256 slots in that memory cartridge, in that save slot. At the moment, everything is 0. Now, each of these spaces, it's a 16-bit or a 32-bit sign integer, not important, but there's 256 of these. From 0 to 255 is how they're numbered. Like that. So if we start at the first one, there's 0. Then 1, 2, 3, 4, 5, 6, 7, 8, 9, all the way up. They're all set to 0. Right. Now, if I look at, for instance, I've been testing the thing. So if I look at what's in the save ID for Classic Snake and I run this, you'll see that there's some data in here. Now, the problem is they all have to be numbers. So I've come up with a way of, let's just go back to, there's a reason that we've been saving our letters as numbers and numbers as letters, because that means that we can just pitch them into persistent memory in a very inefficient but somewhat effective manner and read it back on boot. I have 4 high score slots, but I kind of want to keep it to 5. So 5 high score slots. Each slot is going to occupy 10 values. So to split them out, so the first one, so for instance, slot number 1, our highest score, is going to be slot 10. Then the name for that one is going to be from 11 through 19, which is why I made them 9 long. And then what we do is the first letter will just convert it to its number, save it in 11, the next one in 12, the next one in 13, the next one in 14, until we get to 19. Or if that part of the name doesn't have a name, if it's a 0, it's 0 terminated, so we just stop writing. Okay, and then when we read back, we essentially do this backwards. Now, how do we do that? Well, there's this function called pmem, persistent memory. Right? If you pass it a number, say slot 230, it returns the value of whatever is saved in 230 as a number. On the other hand, if you say pmem 230 and then you give it a number, I don't know, then it saves that number inside that variable, inside that persistent memory slot, air quotes. I have not tried to write anything other than numbers to see what it does, so I don't know how safe it is, but it is a way of writing stuff to persistent memory to sustain across multiple boots. Okay, so we need to go for each high score. So for integer, as always, is equal to, start at 1, and we go for as long as high scores do. Okay, so 1, 2, 3, 4. Then let's call it save slot is equal to I times 10. High score 1 is going to be at 10, high score 2 is going to be at 20, high score 3 is going to be at 30, and so on. So then pmem save slot is going to be the value of high scores at underscore I dot score. So 10 is going to be the actual score. Then for each letter equals okay, but do we need this to be the letter slot, so it's going to be save slot plus 1 going up to save slot plus 9 to give us 11 through 19. For each letter in our name, go pmem that index that we just calculated, and first we clear them. So first we write a bunch of zeros, because 0 does not have an index in this list, which means it's not been assigned, which means there's nothing to write. So 0 terminated string. Okay, it'll make sense in a minute. I've already thought of a bug that's going to happen, but we'll fix that when we get there. Okay, let's for each high score, save score, clear old name, if any, write new name. So same thing basically. Okay, same thing, but now we write the, we need to get the letter first. So local, let's just call it, I'm just underscoring everything. It's a really terrible habit, but it's legible. Set let high scores of that save slot or that high score dot name. Problem is this is going to give us the whole name, and we only need the first letter, or the this manyth letter. Wait, no, this is a problem. This can't be save slot plus 1. This has to start at 1 and then go for the number of characters that's in. It's always going to be 9. the length of high scores I dot name. Okay, so what was I saying? Oh, so the letter needs to be only the one letter of this thing, and we need to do it for every time underscore L as a thing. So you can't index, I think I mentioned this when we wrote setlet, or the getlet, or one of these. Where's this? You can't directly access like letters with index L. You can't do this because it's a string. It's not an array of individual characters the way it's handled in other languages. So we need to do this sub LL basically. So we subdivide the string from an index to an index, and if they're both the same, we get one letter back. So over here, setlet is going to require this, and for itself we do a sub underscore L underscore L. So the name is going to be subdivided from whichever letter we're looking at up until that same letter. Send that to setlet, get back a number for the letter which we then assign. But now we can't just set it to underscore L because that's going to set it on 1, then 2, then 3, then 4. So we need to do this plus save slot, which is then going to give us basically like that 11. We're just doing the plus save slot at the pmem stage instead of in the for loop. Maybe for consistency, just so that they're the same. Okay. Now let me quickly explain everything that's going on here. So for each high score, we do a for loop. That's that. Then the save slot is going to be whatever position in the high score we have. So 10 for 1, 20 for 2, 30 for 3. So the index of whichever score we're saving times 10. Right? That gives us our starting indication. So that's going to be the actual score. So high score number 1 will be saved at 10. 2 will be saved at 20, and so on and so on. Then for the next 9 characters, 1 through 9, we take 1 through 9 plus the save slot. So in other words, it's not 1, 2, 3, it goes 11, 12, 13, and we just set them all to zeros. We have decided that zeros means nothing is saved there. It's also, as you saw in the little app I ran earlier, the mem check, 0 is the default value. So that also tells us that there's nothing there to... What did I press now? Because apparently I'm recording a GIF. Meh. So now I'm completely off my story. Okay, then once we've cleared it to just be all zeros, then we actually write the name. So for each letter in the name of that particular high score slot based on the index that we have above, we first get the letter. To get the letter we call setlet, and of our name we substring each letter one by one. So we start at 1 and we go as long as the name is, which is probably just going to be 9. And then we grab each letter, set it as letter, and then pmem the save slot times the letter, same as we do up here, or plus the letter, same as we do up here. We set that letter. I don't know what button I pressed. There we go. I found what button I pressed. So that's how saving works. When do we call saving our thing? Probably when we're done inputting a name. So this is add new score, right? Add new score ends here. So the last thing we do, regardless of what happened before, is we go save scores, like such. So now I run the thing. Actually, before I run this thing, let's just make these scores a little more legible and a little more basic. So test 1, test 2, test 3, and whatever that is fine. But let's make this like 0, so that I only have to die once to trigger the end of the game. Then 10, 20, let's make it 10, 50, 100. Just so that we have some kind of starting scores in there. Okay, run. See, now those are there. Then we catch a thing, and then die. It prompts me for my name, which I can input, and boop, it's saved. So CEC is now there. It's saved as 1, and now you can't see anything here. Let me just make sure I've saved. Let me quickly go back to that load pmem check. Classic snake. If I run this now, there's our scores. So this data is from an earlier thing. I'm not sure from what. That is my name spelled in there. But now you'll see at 10 we have a score of 100 with, oh look, the names didn't save properly. There's 50. The names all came back as 0. And then 1. So the score saved correctly. The names did not. Okay. Letter. Oh, because it's underscore letter. I'm bad at this. Was that it? So after a bunch of debug work, I discovered that the reason we weren't saving our names is because that's underscore letter, which is funny because I was complaining about the underscore thing anyway, and then this is just called letter. I was missing an underscore. So for consistency, underscore. Now, 1, go, boop. Just save it as with a score of 1. Right, then we go. Okay, ignore the first little part, but there we go. 100 is our score, and then that's T-E-S-T. 50 is our next score, and that's T-E-S-T-2. 10 is our next score, T-E-S-T, I think 3 or whatever was put in there. And then a score of 1 followed by 3 A's. So our score is saving. Our save is scoring. Now we need to load it back in. So, load scores. First we need to check if there is actually information there. If any high score was saved, it would be saved as slot 10, which is our first high score. So if pmem 10 is not equal to 0, in other words, there is at least a value in there. Have scores to load. Then we clear the existing high scores. Then we need an index starting at 10 to read the information from. So we checked 10, there is at least an entry at 10. Now, I've said this before, I hate while loops, but we need to read scores until either our score index is greater than the limit of how far our scores can go, and the score spot we're reading actually has a score in it, so it's greater than 0, because your score can't be negative. Okay. And then, very important, score index needs to increment score index plus 10. Otherwise, this for loop will, this while is going to become an infinite loop. So this line is very important. Okay, so if we find our first high score, which we now know that we will, then we check score 10, then score 20, then score 30, then score 40, or slot 40, until we hit one that doesn't have a high score in it. And for each one of those, we add it to the high score list and then figure out its name and add the name, right? Worst case scenario, if for some reason we have, what's the maximum? 20, we start at 10, so 24 scores in our high score list, which is highly unlikely, but even if we did, then eventually this would just plus 10 up until it hits 260, and that'll be above the 255 limit of our score index and exit the loop either way. Oh, well, this is while it is below that number, and while pmem of a specific score actually has a score. Okay, so the easy part is we make an object. This can actually, just put a bookmark here so I can get back to it. Where do we make our new score? Here we go. I can hijack this. Oh, and this adding score can go now. and this saving to. Okay, so local new score is equal to a new score object that has a score. We're not getting it from score, we're getting it from pmem at score index, and the name is blank. Then for iv in pairs UI entered name. No, this we cannot do. So for each letter starting at score index +1 until we reach score index +9, do new score.name is equal to new score.name plus get let for pmem at L. Right? Because it's going to be a number and we need to get the letter for it from that position. Cool. And it'll go through all of them because the ones that don't have values will be 0, and 0 doesn't have an entry in our list of possible characters, so it'll just not save anything because it'll come back as null. And then when we're done reading this, before we go move on to the next one, we need to add score to our scores. So then we do it table.insert into high scores at position the length of high scores +1. I don't know if this is necessary. I never remember whether if you do a table.insert it inserts at the beginning or the end, but there we go. And then we iterate to the next one and we go again until we hit a save slot that does not have a score in it, and then it stops. So that should do it. When do we load scores? During boot. Now it's fine to load scores during, where the hell is boot? It's fine to load scores during boot because if we just hit a high score and we typed in a new name, then we saved it. So now, theoretically, because this is running on boot, when I run the game now, it should read the scores that we saved on our previous run. It does. Look, there's R. See, there's R that we saved on our previous run and that we saw using pmem check. So now I can have a score of 5. Let's make it, let's write the word 5. Ooh, V is far. This is not ideal, but I don't want to add keyboard controls just to type the name. That sounds like a lot of work. Okay, now it's saved as 5 on 5, and now if I rerun the game, it's still there because it's in persistent memory. We have successfully implemented saving high scores across multiple runs. In the next one, we are going to look into making the high score name save thing a bit more user-friendly. Give it a submit button instead of just submitting when you press a button, showing arrows above and below so that you can see which letter you're editing. Maybe make it blink. The blink is probably the easiest one, just so that that's a little more user-friendly.